Hi, I just wanted to talk through a couple of things just on periodic trends and writing CERs. I've been leaving feedback on your periodic trends lab assessments and wanted to mention a couple of things. First thing is with your claim be specific. So far, this has been good. Follow kind of the whatever questions being asked and respond to the question. For your evidence, you need to include all or just relevant evidence, and it should not be the location on the periodic table. So we don't want location on periodic table. I want to know how many valence electrons something has. So if it is in the second group, then that's saying 2 valence electrons. I also want to know the energy level of those valence electrons. If those are in the third period, I want you to say those valence electrons are in the third energy level. And then number of protons can be helpful depending on if you're talking about coulombic force and those valence electrons are in the same energy level. Then protons is what we use to determine that coulombic force. One other thing is that an atom doesn't go in an energy level. So if you say lithium is in energy level 2, lithium, the element, is not. We're talking about valence electrons. So we can say that lithium's valence electrons are in energy level 2. And so valence electrons go into those energy levels. An atom is not actually in that energy level. When we go on to the reasoning, because your evidence is just that information from your periodic table, tell me specifically how many valence electrons something has, where those are, what energy level, and the number of protons. Once we get to our reasoning, this is when you're going to use comparing words, because you don't need to restate your evidence. We're going to use these comparing words so we can say that there are more or less protons. We can say that the coulombic force is weaker or stronger, or maybe the nuclear charge is weaker or stronger. We can say that the valence electrons are closer or farther from the nucleus. You don't need to restate all of your information because I already have your evidence. So we're going to be comparing the two elements that our claim is addressing. When we're looking at reasonings then, we want to make sure we're using the correct things. You don't need to explain electronegativity in terms of our other trends. Everything is actually going to be able to be explained in terms of coulombic force. So if the question is just asking about coulombic force, then you want to reference that definition of coulombic force, which is that attraction between the protons and the the protons and the electrons. With that, we want to talk about proximity. So that proximity is the energy level of those valence electrons. How close are they to the nucleus? And then you can also discuss our nuclear charge, which is the number of protons. With that, though, nuclear charge is only going to be the tiebreaker when your valence electrons are in the same energy level. And you need to specify that in your reasoning. You need to say, my valence electrons are in the same energy level, which means that protons determines that coulombic force. You should have seen on the data and the pivot that there are elements that have less protons, but that have a stronger coulombic force, and it's because those valence electrons are in a closer energy level. So if your question or if your claim is specific about coulombic force, then this is what you would discuss. When we're discussing reactivity, we're going to also discuss coulombic force. Do we want a strong or a weak coulombic force? And with that, we talk about how can something become reactive. So reactivity is something looking to gain or lose electrons. And we want to talk about that octet. So how can I get closer to that octet? By gaining or by losing? I don't need to reference anything else aside from coulombic force and reactivity when I am writing that reasoning. If my claim is about atomic radius, I do want to talk about coulombic force, and I'm going to talk about that definition of atomic radius, which is the distance from the nucleus to the valence electrons. You might, if your valence electrons are already in different energy levels, that changes that proximity. And so then that's the one time you might not need to talk about Coulombic force. But if those valence electrons are in the same energy level, you will have to talk about how nuclear force influences that distance from the nucleus to the valence electrons, which is atomic radius. If you're making a claim about ionization energy, you're going to need to talk about Coulombic force. How are the proximity of my electrons, what energy level they're in, and that nuclear charge, how are those impacting my Coulombic force, making it strong or weak? And then I'm going to also relate that to the definition of ionization energy. And that definition talks about how much energy is needed, or so the amount of energy needed to remove a valence electron with that. So discussing how a strong or a weak Coulombic force impacts the ability for, or impacts the amount of energy that might be needed to remove a valence electron. And then lastly, electronegativity. You guessed it, we're going to talk about Coulombic force. So does that have a strong or a weak Coulombic force? And the definition of electronegativity. When we're talking about the definition of electronegativity, that is the ability of an atom to attract or to gain electrons with that. So again, you're going to talk about Coulombic force. Does it have a strong Coulombic force so it's more able to gain? Does it have a weaker Coulombic force so it's less able to attract those electrons with that? Hopefully this overview is helpful for you. Please reach out with any questions that you have before the test.